Hello and welcome to this presentation on rotating a linked list. In this presentation, we will walk through the problem, the solution approach, and the code implementation step by step. Let's get started. Given the head of a singly linked list, our task is to rotate left the list k times. In the first example, we have a linked list with the nodes 10, 20, 30, 40, and 50. After rotating it 4 times, the output should be 50, 10, 20, 30, 40. In the second example, we rotate the list 6 times, resulting in the list 30, 40, 10, and 20. Let's look at the high-level approach for solving this problem. We begin by handling any edge cases where the linked list might be empty or no rotations are needed. Next, we calculate the length of the list, then reduce k by taking the modulo with the list's length. After making the list circular, we traverse it to find the kth node. Finally, we update the head of the list and break the circular linkage to complete the rotation. The first step in our approach is to handle edge cases. If the linked list is empty or if no rotations are needed, we can simply return the original list. If k equals 0, no rotation is necessary. Similarly, if the list is empty, we don't need to make any changes. To perform the rotations, we need to know the length of the linked list. We traverse the list and count the number of nodes. This helps us later when reducing k by taking the modulo of the list length. Once we have the length of the list, we reduce k by taking the modulo with the length. This ensures that we only perform necessary rotations, as rotating the list by its length brings it back to the original configuration. Now that we know the length of the list, we make the list circular. This allows us to easily rotate the list without worrying about boundary conditions. By linking the last node up to the head, we can rotate the list efficiently. Next, we traverse the list to find the kth node. This node will become the last node after rotation. We stop at the node just before the kth node because that will become the new tail. After finding the kth node, we update the head of the list to be the node after the kth node. We then break the circular link by setting the next pointer of the kth node to null, thus completing the rotation. Here's the complete code for rotating a linked list. We first handle edge cases, then calculate the length of the list, reduce k with modulo, make the list circular, and finally perform the rotation by updating the head and breaking the circular link. Now let's talk about the time and space complexity of our solution. The time complexity is big O of n, where n is the number of nodes in the linked list. This is because we need to traverse the entire list once to calculate its length and once more to find the kth node. The space complexity is big O of 1 as we only use a constant amount of extra space. In conclusion, we have covered the solution to the problem of rotating a linked list. The key takeaways are handle edge cases, reduce k using modulo, convert the list to a circular one for efficient rotation, and finally update the head and break the circular linkage. Thank you for watching this presentation.